screen? Grades, which is illegal if you're wondering, for me to like give the, like I posted it on YouTube. I took it down really fast, so maybe somebody watched it, maybe somebody didn't. Anyhow, technology, such a disaster. You can use the purple reference sheet. Anyway, so if you watched the video and you saw whole class's grades, I'm sorry. I didn't even know it did that. I didn't even know that was an option, but it is. Okay. We've been talking about congruent shapes. Can anyone remind us what it means to be congruent shapes? Yes. So I literally take one shape, and I can do this, so I can do this, I can bring it over here, but it's got the exact same angles. The exact same angles are going to be congruent, and the corresponding sides would also be congruent. So equal measure, all over the place. Similar polygons are the same shape, but they can be a different size. So they've gone through some type of a dilation. Has anyone gone to the eye doctor and they put that stuff in your eyes and your pupils are like, right? Like your eyes don't become stars all of a sudden. They don't become a different shape. They just get the black part gets very much bigger. Okay, so that's kind of an idea of what dilation means. So polygons are similar if the corresponding angles are congruent. That's the same thing as what we've been doing. So the corresponding angles they still need to be congruent. I don't know why I think about this, but I think about, did anybody have one of those Barbie houses? Like, could you make that Barbie house, but in real life size? So all the angles would be the same. It would be the same shape, just a smaller version. Or like if you've ever seen, if they're building a new town center, or they're building a new ice skating rink, sometimes they'll make a small replica that has the same dimensions, it's just shrunk down. That's an idea. So the angles would still be the same. The corresponding sides, though, they're what we call proportional. So going back to the example with the Barbie house, if I measure the Barbie door and it's 2 centimeters, maybe an actual door will be 2 feet or 4 feet. So you would double it and change the measurements, something like that. And then the height of the door would be times 2. And then the width of the roof would be times 2. That's what proportional is. It gets the same amount bigger in all of the sides. We call the ratio of the corresponding sides the scale factor. A lot of kids said they heard this last year. Some kids who went to Spring Creek said they did like a scale factor project. They didn't like it either. I've seen people do scale factor where they'll give the kids a candy wrapper and then graph paper, and they have to make it bigger or smaller. I don't remember now. Mm-hmm. Wow. Well, hopefully this won't be as terrible as that. If polygons are similar, then their perimeters are also proportional. So if all the sides are twice as big, then the perimeter is twice as big as the other perimeter. Okay, we're done with kind of our vocabulary section and definitions. We're going to move down here to scale factor. When it says the order matters, let me explain. So if I have a shape, and let's say the side is 1, and then I go to this shape and the side is 4. What's the scale factor? 4. What about if I go the other direction? What's the scale factor? 1/4. So if I say the scale factor this way and you say 1/4, that is wrong because the order matters. So I have to write this for me. When I'm trying to find a scale factor, the numerator is where I'm going. And I'll show you what this means in a minute. And the denominator is where I started. If you leave the numerator where I'm going and the denominator where I start, you'll never accidentally have the scale factor upside down. It just won't happen. So for example, when it says, what is the scale factor from triangle ABC to triangle DEF? So let's just make sure these are corresponding sides. We've got 2 dashes. Oh, that has got to be so loud on the microphone. 2 dashes and a triple dash. 2 arches and the triple. So these are definitely corresponding sides. So where am I going? I'm going to this 15. And where did I start? I started at the 10. You can use any of the sides. It doesn't. You can use 8 and 12. You can use 14 and 21. You're going to get the same proportion if they're actually similar, which it said that they were. And then we reduce this. Did you all reduce it already? Bergen, what is 15 tenths once you reduce it? Yes. Okay, so like we talked about a second ago, this one's now saying, what is the scale factor of DEF to ABC? So it's going to be the opposite. Let's use different numbers though. So where am I going? I'm headed to the smaller one. Where am I coming from? I'm coming from the bigger one. It's not hard with whole numbers. Like when I said times 4 or divided by 4, those aren't the hard ones. These ones that are mixed numbers and fractions, I think they're more difficult. Tanner, what is 14/21's reduced? Yeah, 7 goes into 14 twice. And it's set up above. If polygons are similar, then their perimeters are also proportional. So this one says the ratio of the perimeter of DEF to ABC. So it's like this again. So find the perimeter, 14 plus 10 plus 8. Is anyone fast at that? And the perimeter, this one is 48. So when I'm finding that ratio, where I'm going, where I started, and we're talking about the perimeter, we added all the edges together. And you reduce it. What's it going to be? 2 over 3, which is going to happen every time. The perimeter will have the same ratio as the individual sides. I feel like I'm going a little bit fast. So I'm going to sit here for a second. Okay. Just how we learned what congruent, we had an equal sign with like a squiggly line on top of it. We also have a symbol to represent similarity. It's just the squiggly line. And it reads, this is similar to this. So looking at our triangles up above, I can say triangle ABC is similar to triangle DEF. Meaning, the definition up above, the corresponding angles are congruent, the corresponding sides are similar. Okay, any questions so far? This is basic, just getting to know what the words mean and the symbols. Okay, we're going to practice writing congruent and similar statements. So, actually, my stomach is hurting really bad. I'm going to run to the restroom. Who wants to keep going with the notes? Who's feeling confident with this? No one? Okay, you win. If you can't figure it out, I'll be right back. Well, if you want. Otherwise, you can just wait a second. Actually, will you go push stop on, or pause? Not stop. Push pause. Sorry, I had one of those emergencies, because I feel like I'm getting a cold, and my body was like, no, thank you. Okay, here's the part that's important, and I think a lot of people missed the importance of it on the test, so I want to take a second to mention this. The order that these are in matters, especially, can you tell that it's been twisted around? Like I can't always assume that bottom left matches up with bottom left. It may not, okay? So I come up to this statement and J has to match up with P because they are the first letters in the similarity statement. And then you can see Keegan was copying my notes, but they have a single arch. Or you can put a double. It doesn't matter which one you begin with. Then the next ones, K and M would have to match up. So K is here, and M is here. And then obviously the final one is that third one, angle L and angle N. And I feel like you can use those dashes now, or the arches, whatever you want to call them, to find the corresponding sides. If not, I come back to the similarity statement, and side JK, see how it's those first two letters? It's going to be the corresponding side with PM, those first two letters. Sometimes it's easier to figure out than others. This one's kind of tricky because it's rotated, and I think it's reflected. So it's got a lot of stuff happening. So again, KL and MN are the second set of letters. And then the third one's the only one that's left over. So you can use that to help you write these similarity statements. Hey, Baxter, are you going to come teach too? That's so good. This is actually the nicest thing about teaching high school. At middle school, you just don't leave your class. You come back to complete anarchy. Okay, this one is kind of interesting because can you guys see like which angles and sides? Like this is pretty obvious, but they're kind of on top of each other. So let's talk about the angles. Angle X and angle R are congruent. Oh, and my notes were funny. Instead of writing and, we should write that they are congruent. Angle X is congruent to angle R. Angle Y is congruent to angle Y. Do you guys feel like this one is more obvious than this one with rotating and reflecting? Okay. The last one is angle S is congruent to angle Z. If you're going to be up here, you should at least go get your paper. You're one of those kids. All right, let's look at the sides. I had a student, I didn't mean to call on him for this reason, but he said side XR. Is that the side of a triangle? No, that's not a side of a triangle. RY is the side of the small triangle, and XY is the corresponding side of the big one. We don't use this piece for anything with the triangles. Okay, so we would never use XR on one of the sides. RY is similar to XY. So will you complete writing those similarity statements? And if you're super fast, there's one more on the back. Is that true? Yes, if you're super fast, there's one more on the back. You can practice writing those similarity statements. Make sure you're taking the notes. Just a second, let me put this on my desk. Is that too low for you guys in the back? Is that better? Yes. This is a small triangle. This is the big triangle.
So saying if it were Z and S right here, we could just that's why not the Y.
That's your next one, yes. These aren't the same thing. This was the angles. This is now the sides. You don't forget about it. It just doesn't affect what your line statements are. Find another side. Do you want to do these two sides or do you want to do these two sides? It's your choice. Yeah, so those are also similar.
So say I wanted to do RS and SR.
No, RS is similar to XZ. Small triangle, big triangle. All right, let's finish these statements up. Ashlyn, what was your next sides similarity statement? And these letters, you could have written those letters backwards. This part is not directional. You could have called it ZY and SY. You could have even put this one first and that one second, but you just have to mention this side. Josh, what did you write for this final side of the triangles? XZ is similar to RS, yeah. And again, you could call it ZX, you could call it SR, you could put the SR first. Those orders don't matter. You just need to make sure that you mention all three of the sides. Like, don't leave one out. Okay. We're not going to spend a lot of time going over this one, but the biggest thing I want to mention, we clearly have some type of a rotation, maybe even a reflection. So before you start doing problems with them, I would come and double check J and Q match up because they are both the first letter in that similarity statement. K and R match up. L and S. And M and P. It's a lot of markings. Okay. Is there anyone who feels like they really need to do this one as a class? Okay. All right. When we've moved on now from finding the proportionality, making sure we are looking at corresponding sides or angles, to using the similar figures to solve for a missing measure. So Carter, will you read the number 4 for us? Ethan, how do I know which one's the 2 and which one's the 3? What would you guess? I was thinking the same thing. I thought, is this going to be something complicated? Is it like the order that they say them in? Is it the first one is the top and the... No. If you have 2 numbers and you can visibly see there's a smaller one, give it the smaller value. So this has a ratio of 2 to 3. There's a couple ways to find the missing side. I'm going to show you one. There's quite a few kids who were like working this magic in their mind. They're like, I know the answer. I can use, they're multiplying and dividing or whatever. We're going to use proportions. So I'm going to do 2 over 3. And I'm going to set it equal to 42 over x. Now, having the 2 in the numerator, not important. Having the x in the denominator, not important. The thing that is very, very, very important, you'll get the wrong answers if you mess up here. I chose to do small triangle. I don't know why I called that a triangle. Small parallelogram over big parallelogram, small over big. So my next fraction has to be that also. I have to go with something from the small parallelogram on top and something from the large parallelogram on the bottom. That's what's important. Yes? Yes, which is what we're going to do. We're just going to do the opposite of that. Anyone remember how to solve the proportions? Most middle school teachers call it the butterfly method. Does that ring a bell? So you cross multiply. We will do x times 2. So this is where, I don't know if you heard Jesus, he said, can I divide by 3 and times by 2? Yes, we're just doing that backwards. We're timesing by 2, and then in a minute we'll divide by 3. 126. And then we'll divide by the 2 second. You just did it in the opposite order. And then we're just solving. So Davis, how do I solve for x? Yes. All right, let's look at the next one. Allison, will you read number 5? Allison, which one do you think is the 6? Which one do you think is the 5? Yeah, I really don't think it's any more complicated than that. If it looks bigger, make it the bigger number. If it looks smaller, make it the smaller number. Hayden, how would I set up a proportion on this one? And there's 4 proper ways to do it, so we'll see which way Hayden picks. If you decided that the big triangle will be in the numerator, it has to stay there. So x and 28 are definitely the numbers we use, but by putting the 6 on top, you decided that the x would have to also be in the numerator. Okay, go ahead and solve that one. I want to make sure we don't have any issues with solving, because if we don't have issues solving, I'm just going to fly past that part. We'll just work on setting up the proportions. So you might want a calculator, unless you can do 6 times 28 in your head. Okay, go ahead and solve that one. Yes, good. Oh, yes, good. You got it, Carter? No, you don't have a calculator. Half of you don't have calculators today. Yes, good. Yes, good. Yes. Are you stuck because you don't have a calculator? Oh, well, write it down. Yes. Yes. So can you finish solving that? How do you solve for x? So what will it be? All right, once you solve these, which some of you are doing, some of you are just not doing it. It was a decimal, 33.6. Some of them are hard to do in your head. Okay, let's look down at number 6 and number 7. Lacey, will you read number 6 for us? It's similar to. All right, any ideas how I would set this up? Peyton, what do you think? Isn't it hard? Because I don't know if the x matches up with a 25. I can't really tell if the x matches up with a 20. So just take the time to look. Side A, B, and you can do something to show, you maybe don't have colored pencils or something, but do something to show that side. Corresponds with side DE. So those should go together. I'm just going to make sure BC and EF. Okay, and now can you set up a proportion? over 28. So he chose to do small triangle green over big triangle green. Small triangle red over big triangle red. I can't emphasize, there's 4, Ethan, close your computer. There's 4 ways, Hayden, you should probably close yours too. There's 4 ways that you can set it up. 4 correct ways. Okay, I think you all know how to solve it, at least I hope so. So let's look at number 5. Will you please set up your proportion statement for number 5 or number 7 and then solve it? I'll give you a minute. Once you're done, if you can tell your neighbor's done, compare with them. Make sure your numerators are, or make sure your, cross product is matching up. You're welcome. If you finished 6, x would be 35. If you're wanting to check that. So write your proportion statement, something over something equals something over something. Mm-hmm. 700. Mm-hmm. Yeah. Yeah, it's easy. It's easy. A lot of the math in geometry, all of the math in geometry is algebra. It's a review from first trimester. It's just the setting things up that's new. Which side? So that's, sorry. So like on here, PQ is a side. You just pick 2. So PQ is just this side. And then WX is going to be that side. Then you can go to QR and XY. So QR and XY. Now I'm guessing it's just going to keep going around. So then when you go to set them up, you do it 40. That's the 4 dashes over 75. Okay, did we all get the same proportion here? Okay, so something you may want to do before, side PQ is corresponding with WX. QR corresponds with XY. And it looks like it's just going to go around from there, but RS corresponds with YZ. Then you'll make sure that you're matching up the corresponding sides. Edwin, will you tell us what your statement, your equation is, excuse me. I saw you had something. Just tell us what you wrote. $40 over what? You got your 4 dashes over. Equals. So we got to go back to the small triangle. Over x. If you didn't do small triangle over big triangle, yours might all be flipped. That's fine. We're going to get the same answers. There's lots of different ways to write these proportions. Okay, for those of you who already solved, you should get, which one is this? X equals 60. Okay, we're going to do one more, and then I'm going to let you work on your stuff. Same idea. We just have more complicated looking sides. So we'll start out, side AG is corresponding to side KX. This just is just helping make sure you match them up together. And then side GM matches up with side XD. That's the only one left. What's your question? So Sophie, how can we set up a proportion? Will you help me get started on it? Yes. I can't emphasize, yours could be upside down from that. Yours could even be like twisted 90 degrees. But the important part is she decided that this smaller looking triangle would be on the numerator and this bigger looking triangle would be on the denominator. Okay, when I use the butterfly method here, that's why when some of you were doing them in your head earlier, make sure you pay attention to this butterfly method. It's 32 and x plus 6 equals 36. I'm going to run out of room. X plus 3 and we'll just solve it. Like first trimester, we distribute. We move the same terms onto the one side. And I'm not going to go through number 9. It's the same. So focus on making sure you're looking at corresponding sides, then set up those proportion equations. Any questions on how it's set up or how we knew which sides were corresponding? Yeah, Camden, how would I solve now? Yes. 32 times 6, huh? 32 times 6 is 192. Oh, why did I put plus? Oh. Okay, I'm going to pass out your practice page. If you're not sure what it's asking you to do, look at the other side of your notes. Your notes went through each of the sections one at a time and gave you good examples to refer back to. Yes. Just slide it down to her. Where's Carlos? He was here today. Extra? So on the other side, again, turn your notes page back over. If you finish solving number 8, it is x equals 21, if you want to make sure you did it right. (84 divided by 4). 21.